Hello everyone, and welcome to this introduction to Amazon EC2. Today we'll be diving into the fundamentals of Amazon EC2 and understanding how it enables cloud computing. Whether you're new to AWS or looking to strengthen your cloud knowledge, this session will give you a solid foundation on EC2 and its use cases. Let's get started. Amazon EC2 is a service that lets you run virtual computers in the cloud. The word elastic means you can easily adjust how much power you need depending on what you're doing. If your app suddenly needs more processing power, EC2 can quickly provide it, helping your work run smoothly. This flexibility is one of the main reasons people use cloud computing. Normally, with regular computers, you'd have to buy a physical server, set it up, and keep it running. But with EC2, you can create virtual computers called instances in just a few minutes. These instances work like regular servers, but they're in the cloud. You can turn them on, off, or change them whenever you need to. One of the best things about EC2 is that you don't have to worry about managing physical computers. You won't need to buy expensive servers or worry about maintenance, cooling, or upgrades. AWS takes care of all of this for you. You just focus on running your apps, and EC2 handles the computing power. EC2 is built to be used for different tasks. Whether you're running a website, analyzing big data, or testing out new apps, EC2 has different types of instances to fit your needs. Plus, you only pay for what you actually use, which helps keep costs low. With autoscaling, EC2 can adjust its resources to match your needs, saving you even more money. One of the best things about EC2 is that it can grow or shrink with your needs. Imagine you have an online store. On regular days, not many people visit, but during sales or holidays, you get a lot more traffic. With EC2, you don't have to worry about buying extra servers ahead of time. Instead, you can add more virtual computers when you need them and reduce the number when traffic is low. This helps keep your website running smoothly without wasting money. EC2 gives you full control over your virtual computers. You can choose which operating system you want, like Linux, Windows, or others. You can also pick the right instance type based on what you need, whether that's more processing power, memory, or storage. EC2 also lets you set up networking, like placing your virtual machines in different locations for better reliability. And you can choose different storage types, like fast SSDs or cheaper hard drives. This flexibility makes EC2 a great option for many different types of applications. Normally, you'd need to spend a lot of money up front for hardware that might not always be used. With EC2, you only pay for what you use. For example, if you run a virtual computer for just a few hours, you'll only be charged for that time. This pay-as-you-go system makes EC2 a great cost-effective option, especially for startups, testing, or short-term projects. AWS runs one of the largest and most reliable cloud networks in the world. EC2 instances are hosted on AWS's global data centers, which are built to stay up and running. Each region has multiple availability zones. These are separate data centers that help keep things running smoothly. If one data center has an issue, your EC2 instance can keep running in another one, making sure your app stays reliable. Security is very important in cloud computing, and EC2 has built-in features to keep your data safe. With AWS Identity and Access Management, you can control who has access to your virtual machines and what they can do. For example, you can set up rules to make sure only certain users or apps can start or stop your instances. You can also set up security groups, which act like firewalls to manage the traffic going in and out. Together, these features help keep your applications and data protected. One of the most common ways people use EC2 is for hosting websites and web applications. Instead of using traditional web hosting, businesses can run their web servers on EC2. This gives them the ability to easily adjust to traffic changes. If more people visit the site, they can add more virtual computers, and if traffic drops, they can reduce the number of virtual machines to save money. For example, a startup with a new website can begin with a small EC2 instance and later upgrade it as more people visit. EC2 is also used to run databases and backend services. While AWS has services like Amazon RDS for managing databases, some businesses prefer to run their databases directly on EC2 for more control. You can run databases like MySQL, PostgreSQL, MongoDB, or Oracle on EC2 and set them up however you need. You can use EC2 to host back-end services like those that power mobile apps or websites, helping them run smoothly and connect with databases. Companies that work with large amounts of data or need a lot of computing power, like those in finance, healthcare, or e-commerce, often use EC2. EC2 offers high-performance virtual machines that can handle big data, train AI models, and run complex calculations. For example, a company might use EC2 to process a real-time data, predict market trends, or detect fraud. Many modern apps are built using something called microservices. This means the app is split into smaller parts, each running on its own. EC2 is great for this because you can set up different virtual machines for each part of the app, making it easier to scale and improve the app's reliability. For example, an online store might use separate EC2 instances to handle payments, manage orders, and verify users, letting each part grow independently based on how much demand there is. Developers often need separate environments for testing their apps. Instead of using their own computers, they can use EC2 to create different environments for testing. For example, they might need to test apps on different operating systems or check how updates work in a controlled setting. EC2 is also useful for continuous integration and deployment, which automatically tests and deploys new code using EC2. AWS has a large global network with multiple regions around the world. A region is simply a physical location with AWS's data centers. For example, AWS has regions in places like North America, Europe, Asia Pacific, South America, and the Middle East. This global network lets businesses run their applications closer to where their users are, improving how fast and reliable their services are. Each AWS region is made up of several availability zones. An availability zone is like a separate data center with its own power, network, and cooling systems. Having multiple AZs in a region helps make sure services stay available even if one data center has an issue. If something goes wrong in one AZ, your workload can automatically move to another AZ, keeping things running smoothly. When you launch an EC2 instance, it's important to choose a region that is closest to your users. This helps reduce the latency, which is the time it takes for data to travel between your users and your servers. For example, if your users are in Europe, hosting your EC2 instance in London or Frankfurt will give them faster response times than hosting them in North America or Asia. While most AWS services are available everywhere, some services are only available in certain regions, or they might cost different amounts depending on the region. For example, some machine learning tools or databases may only be available in specific regions, and some regions may be cheaper than others. Before you start using EC2, it's a good idea to check which region has the best mix of availability, performance, and price for your needs. The on-demand pricing model is perfect for short-term or unpredictable needs. With this model, you only pay for the time your EC2 instances are running, either by the hour or by the second, depending on the instance type. For example, if you're testing a new app and only need a server for a few hours, on-demand instances let you start and stop your server without any long-term commitment. While it's flexible, it can become expensive if you use it for long-term projects. If you have something that needs to run for a long time, like a database server or an important application, reserved instances can save you money. By committing to 1 year or 3 year terms, you can get discounts of up to 75% compared to on-demand pricing. This is great for businesses that know they will need the same resources for a while and want to lower their costs. AWS has extra computing power that's not being used, and spot instances let you bid on this unused capacity at a much lower price, sometimes up to 90% cheaper than on-demand instances. However, these instances can be interrupted if AWS needs the space back, so they're best for workloads that can handle interruptions like batch processing, big data analytics, or testing. For example, if you're training a machine learning model and it doesn't need to run without stopping, spot instances can help save you money. Saving plans are a more flexible option than reserved instances. Instead of locking into a specific instance type, you commit to a certain amount of compute usage for 1 or 3 years. This model gives you discounts on several AWS services, not just EC2. So if your needs change over time, you won't be stuck with one type of instance, making it a great option for businesses that want flexibility while still saving money. EC2 instance types are different configurations of virtual machines, each with different resources like processing power, memory, and networking. You choose the one that fits your needs. For example, if you need a lot of computing power for a complex task, you can pick an instance with more CPU and memory. AWS has different families of instances for various tasks, like compute-focused, memory-focused, and storage-focused instances. An AMI is a pre-configured template that contains everything needed to launch an EC2 instance. You can choose from AWS's ready-made AMIs like Ubuntu or Windows Server, or you can create your own custom AMIs to make launching instances faster. This saves you from setting up everything from scratch each time you start a new instance. Elastic IPs are special, static IP addresses that you can use with EC2 instances. Unlike regular static IPs, elastic IPs can be moved from one EC2 instance to another. This is helpful when you need a fixed IP address for your application, even if the underlying instance changes because of scaling, failure, or recovery. Security groups act like virtual firewalls, controlling the traffic that can enter and leave your EC2 instance. You can set rules to specify which IP addresses and ports are allowed to access your instance. Security groups are stateful, which means that if you allow inbound traffic on a certain port, the response from that port is automatically allowed. This makes managing security flexible and easy. Elastic Block Store provides storage that stays intact even if your EC2 instance is stopped or terminated. Unlike the Instant Store, which is temporary, EBS volumes are perfect for storing data you want to keep, like databases or application files. You can attach multiple EBS volumes to an instance and even change their size without stopping the instance. Autoscaling helps you automatically adjust the number of EC2 instances based on how much demand there is. If your website gets more traffic, autoscaling can launch more instances to handle the load. Once traffic goes back down, it can scale the instances back down to save costs. This ensures your application stays available and cost effective. When it comes to scalability, EC2 is much more flexible. It can automatically adjust resources like the number of servers based on demand. With features like autoscaling and elastic load balancing, EC2 can quickly respond to changes in traffic. In contrast, traditional hosting requires you to manually add more hardware or upgrade servers, which is slower and more costly. EC2 is on demand, meaning it can scale quickly and efficiently to meet your needs. EC2 uses a pay-as-you-go pricing model, which means you only pay for what you actually use, like computing power and storage. This is great for businesses with changing needs because you can adjust resources based on demand and avoid paying for things you don't need. Traditional hosting, however, often charges a fixed monthly fee for a set amount of resources, so you might end up paying for unused capacity, especially if your needs vary from month to month. With EC2, AWS handles most of the hard work, like managing the hardware, networking, and power. You still manage the software and security, but AWS gives you tools to automate a lot of the work, making it easier for you to focus on running your application. On the other hand, traditional hosting requires more hands-on maintenance because you're in charge of both the hardware and software, which means more time and expertise to keep something running smoothly. EC2 lets you deploy applications much faster than traditional hosting. You can launch new instances in minutes and use pre-configured AMIs and tools like CloudFormation to quickly set up and scale your environment. Traditional hosting, however, often takes longer because you need to set up the hardware, install the operating system, and manually configure everything, which can delay your project and make the setup process more complex. To wrap things up, Amazon EC2 is a powerful and flexible service that makes it easy to scale your resources and save money. It's a great choice for all kinds of applications, whether you're hosting a website, running a database, or working with machine learning. EC2 offers different pricing options like on-demand, reserved, and spot instances, so you can choose the best way to pay based on your needs. Next, we'll dive into the hands-on lab, where you'll get to set up an EC2 instance as a web server. This will give you a chance to practice what we've learned and gain some real experience using AWS EC2. Let's take a look at a basic AWS architecture, where a client accesses a website hosted on an EC2 instance. In this setup, the client, which could be a user on a laptop, desktop, or mobile device, connects to the website over the internet. The request travels through the public internet and reaches the AWS cloud. Within AWS, we have a virtual private cloud or VPC, which is a logically isolated network. Inside this VPC, we have a public subnet, a network segment that allows resources to be accessible from the internet. The EC2 instance, which hosts the website, is deployed in this public subnet. Since it's in a public subnet, it has a public IP address or an elastic IP, making it reachable from anywhere on the internet. To ensure users can access the website securely, we typically configure a security group, which acts as a virtual firewall. It controls inbound and outbound traffic, allowing HTTP or HTTPS traffic from the internet while restricting other access. This architecture is simple but effective for hosting a basic website. Hi all, and welcome to this hands-on lab where you will learn how to deploy a simple web server on an Amazon EC2 instance. Amazon EC2 provides scalable virtual servers in the cloud, allowing you to run applications with flexibility and control. To start with, we're going to go to the EC2 console. We're going to launch an instance. Here we'll put the name as web server. We will use the default Amazon Linux AMI, and we're going to stay on the T2 micro, which is in the free tier. For a key pair, we're going to create a new key pair and call it web server key. Creating the key pair will download it to your computer. Under the network settings, we can see the VPC that we'll use, and the subnet isn't defined, so it's going to use a default subnet in the AZ. It's also going to assign a public IP address for us. It's going to create a new security group, and on that security group we can use some defaults like allow SSH traffic from anywhere, allow HTTPS traffic from the internet, and allow HTTP traffic from the internet. So that is your port 443 and port 80. We're going to launch the instance now. Coming back to instances, we should be able to see our web server running. If we come down to security and scroll down, we'll be able to see the security group rules for inbound and outbound. Outbound is allowing all traffic, and inbound is allowing port 80, port 22, and port 443 from any source. To access the server, we're going to go to the details, copy the public IPv4 DNS, and SSH to the server using the key that we downloaded. We're going to SSH as the EC2 user. Now that we're on the EC2 instance, we can install the web server. We will also enable the web server and start it. Our web server is now running. We're going to add a default page for our web server, and we're going to have to sudo in order to do so, and we'll use index.html. Now, if we browse our EC2 public IPv4 DNS, it should show our web server. Note that when we open it, it's going to default to HTTPS, which we haven't installed yet. So we're just going to remove the S so it goes to the port 80 HTTP. Here we can see that our web server is running. If you are having issues accessing this page, make sure that the HTTPD is running. If that's running, also make sure that on the security, on the inbound rules, you have the port open for your IP. Once we're done, we can terminate the instance, and to ensure a full cleanup, we'll go and we'll delete the key pair as well. That's it for the hands-on lab. Thanks for joining.